Alright, hello world, welcome back to another video. In this video we're going to keep doing some Leetcode challenges. Let's take where we left off, which is this maximum subarray. So, recall basically I will link the first video down in the description below. You can check it out, see how me sucking at these Leetcode questions. But yeah, basically we implemented a brute force solution. That's just going to brute force through all the possibilities, but of course we know this is Leetcode. If we have brute force something, it's always not going to work. So it's not working, and but I still want to have the solution here, so we can compare and contrast it. All right, just gonna write it here. However, now we're gonna use some algorithm to help us to do it faster. One algorithm we're going to use is going to be called divide and conquer. Since I have never used this algorithm before, that's why I'm sucking these Leetcode questions, and that's why I want to get better at it. We're going to read through this tutorial made by Geeks for Geeks, which I think is pretty good programmer tutorial websites. Okay, so divide and conquer. All right, let's take a look. This involves dividing a problem into some subproblems. Conquer subproblem, calling recursively until subproblem solved. The subproblem solved, so that we'll get find the problem solution. All right. So some standard algorithm that follows, which I don't know any about them, so we might need to take a look at them too. Alright, these images are readable, whatever. All right, let's see. So what is it? What does not qualify? All right. Let's see for managed to take. Oh god, which is unreadable. When there's a power of. Gotta read through these maths. I hate maths. See, that's why I don't like Leetcode. What's this small doing? Did not explain what this is. I forget it. We will Google something better. I'm still a little bit confused. Divide and conquer. Oh, Khan Academy. Let's take a look at this. Okay. Alright, okay. Divide and conquer. Okay. Right, okay, so, well, this brute force won't work. So I'm thinking, is there a better way to, make it go faster? Let's see. Right, because the problem is I do not know how to divide them. That's like the main problem. I do not know how to divide them. Because if I want to divide them, then that's just become another brute force thing. All right. Okay. Well, looks like I cannot unlock the solution. All right. Well, I don't want to say this, but I want to take a look at the answer, since I have absolutely no clue. Well, that's a solution. I guess what I wanted to do is see if I can make it go faster. Still using this brute force approach. Just make it go faster, I think. So let's see. Let's submit, let's run the code again. Right, we cannot pass this test case like anyhow. That's what like I'm struggling on. So, I guess if we there's so many. Alright, well, I don't think we need this times anymore, do we? I'll just delete that. Because every single time matters. I don't think this is gonna pass, because I don't think that millisecond matters that much. But who knows? Yeah, it's okay. Well, I'm definitely not good at these Leetcode problem. That's why I want to do them. Okay. Well, I really want to get past this problem today. We don't need to use times, so that's for sure. Okay, so now to see if there's faster way. Let's take a look. Let's take a look at some contain algorithm. or something. Okay, let's initialize maximum so far. Maximum ending. Loops through each element of the array. Max ending here. Okay, let's take a look. Maybe this is actually gonna work. Okay, so Candine's algorithm. All right, so let's go do that. Let's copy this. Brute force. Please tell me copy paste is allowed. Thank God. Okay. All right. Okay, so let's see. Let's implement this algorithm. So actually, let's look through the explanation first. The simple idea of Candine's algorithm is to look through for all positive contiguous segments of the array. Max ending here is used for it, and keep track maximum sum among all the positive segments. Each time we got a positive sum compared to a max so far, and ooh, okay. So now just skip all the negatives. So you just skip all the negatives. If j is not 0, what? Why did I do it? J is not. Oh, okay. And let's do this. If j is less than 0, and let's continue. So that could work. Oh, shoot. Okay. Let's call this again. There we go. So if it's negative, then we skip it. Will it still work, I wonder? Alright, still got this time exceeded. I really want to figure this out. So, let's see. Okay, looks like it still works. 200 out of 203 test case passes. Okay, now, let's see. So, instead of storing the results, I think what we'll do is do a max so far. And in here we'll say if we do a break. See if this works. Results is not defined. Okay. Let's define results again. Okay, so I wonder if break works. That's gonna fast our thing a lot. Okay. Let's submit the code again. So I really want to figure this out. By whatever mean possible. Don't want to really just straight up copy stuff. Next time, should really start with some beginner challenges. I don't think this is beginner enough. I want this is. I want to make sure it's that it does pass all the test case. I think it does, because if it doesn't, it will show an error already. Yeah, so break works. Despite we have break, it's not fast enough. So I think what we can do is we can have a max so far. If we can say this, if it's greater than max so far, then max so far equals to this. Let's say max current. Max current equals to this, and then we don't have to append anymore. If sum, if max current is greater than the max, so max current equals now bracket 0. Let's run a code. Oh, shoot, okay. Should give it area. Num's not defined? Nums, okay. That's not this, return max so far. So if I have negative number, you can just skip this entire iteration. Let's see how fast would this give us to. Even if we pass it just by edge. Oh, we got a wrong answer actually. Oh shoot. Oh. Okay, nums bracket 0. Alright, this is stupid. Yeah, I don't have to have this then. Make sure it works. Submit. Yeah, I still exceeded. Right, I don't think. Yeah, I think it's really in essence really too slow. Okay, so yeah, I think we'll just to implement this. Loops through each element. Okay. Let's try to implement this. Max so far. Brute force. Alright, yep. I'm officially gave up. Because I do want to, because I do have a lot of stuff I need to do today. Alright, max up array. Okay. Let's initialize it. So max so far. A 0 and max ending. 0. So these are to initialization. And we're using this to track. So max ending is used for positive contiguous segment. Okay, so now let's go loops through each element in this array. Okay, so now what we're going to do is we're going to say max ending here equals max ending plus a every time we gotta. Alright, let's see. So max ending here. I'll link this article in the description down below, by the way, if you want to check it out. Hopefully I remember that is. Equals to a plus equals nums bracket I. I'm not sure why this line is. Max ending here. Max ending. Okay, so let's see. If max so far is less than max ending here, then I want to say max so far equals to max ending. Alright, and then we'll say if max ending equals max ending less than 0, then max ending equals 0. Return max so far. Alright, let's run the code. Alright, finished. So it works. I think it should work since it passed that test case, but I'm a little bit confused on the algorithm I'm using here. And we got a wrong answer. Because max so far is nums bracket 0. Not just 0. Oh, there we go. Accepted. Alright, let's take a look how fast this algorithm is. Thank God. Alright, I'm gonna paste it here. Okay, so let's review the algorithm that we're using here for my sake, because I'm not smart. Okay, let's use the example. So max so far equals max ending here equals 0. So max ending here. So max ending here is used to look for all positive contiguous element in an array. Let me see. Okay, not bad. Not bad at all. Alright. Okay. Let's see. So if max so far is less than, so max ending plus equals to nums bracket I. That means max ending is, if we are using the example that we have here, then that is -2, for example. So if it's -2, then we'll say if max so far, so that's -2 is less than max ending. Oh, max ending is a way to keep track of, it's like the end. Okay, it start making some sense. Alright, max so far equals to max ending. Okay, yeah, so max ending is some sort of like the end value. And then, so it's basically checks that if the ending value is less than max so far, I'm gonna set to max ending. Max, then we're gonna set to 0. Okay. Okay, well, this loop gonna run again. If it's 1, then now max ending is 1. So the 1 should be 4, -1, 2, 1. So let's see how it'll work once it reaches there. So since it is negative, it'll still be 0. So that max ending is 4. Oh, max ending added the 1. Oh, so max ending is also the one that keep track of all the sum. But if it's a negative values, then that means we can safely skip it. That makes sense. Okay. Well, that's good to know. I would like to submit again just to label the credit there and also show my stupid brain for. I'm not going to cover the stupid. This is a way, but definitely not the most efficient way. So gladly that I learned some great algorithm here. That's good. And yeah, I think that's going to give a wrap to this Leetcode. And let's do spoiler alert too. What's this? Oh, got some hint. Let's see. Oh, to the end of it. Okay, this doesn't seem that hard. I do not know, but we'll double check. Well, yeah, but yeah, thank you for watching this video. If you have any questions or comment, feel free to comment down below. And as always, stay safe and have a great rest of your day. That was me, out.